Okay, let's discuss the model assumptions for my simulating natural selection project. These assumptions are based on the videos by Primer. So if you haven't seen those yet, with the the blobs, that's a great I think they're great, right? So go and take a look at those if you haven't done so already. And we're going to try and emulate that model to begin with. But we're going to do it in one dimension. We're going to simplify it. We're going to make it into one dimensions rather than two. So first of all, we're going to create some environment in which for our organisms to exist, we're going to essentially define a one-dimensional straight line of size x. Okay. We're going to distribute pieces of food randomly across that environment with some coverage density rho. So for example, if I want a 10% coverage and my line is x equals 1,000, there will be 100 pieces of food on the line. Okay. We are going to let n organisms inhabit the environment at any given moment. And to begin with, n might equal 1. In fact, it will to begin with. Those organisms, when we define them, will possess three key variables. Firstly, it'll be their speed, v, their position, p, along that line, and the direction that they're going to move in, j. So the speed and position will only take integer values. So for example, if v equals 1, that means for every cycle of our simulation, they will take they will step by 1. So for example, if they're at position 99 and they're moving forwards, they will then take a step to 100. Okay, if their speed is 2 in one cycle of the model, they will go from 99 to 100 and to then 101. Okay, and that's how we're gonna get them to move. So those speed and position variables will take integer values. Okay, I don't want a model which has continuous variables in, because that can get a bit complicated later. Every time the organism moves, it's going to check to see. Actually, we'll talk about eating food in a sec. I'm first going to say that they will move s times in a day, and for the purposes of this model, 1 day is going to give us 1 generation. So they're either going to die or they're going to survive at the end of that day, or they're going to survive and reproduce. Okay. When an organism encounters food, this is the juicy bit, right? If they haven't eaten any food yet, they will eat the food. So that food will be removed from the environment, and that organism will have a counter associated with them that will tick up by 1. Okay, so they'll all start, every organism at the start of the day will have food equals 0. If they eat some food, they'll get to food equals 1. If they eat 2 pieces of food, they'll go food equals 2, and then they'll stop eating. In fact, they'll just stop. They won't continue to move. And when all of the organisms in the environment have eaten 2 pieces of food, or all of the food is being consumed, the day will end. Okay, and then at the end of that day, if an organism hasn't eaten anything, it will be removed from the environment. In other words, it dies. If at the end of the day he's eaten 1 piece, it will survive until the next day. And if it's eaten 2, not only will it survive, but it will reproduce. And when I say reproduce, it will spawn spontaneously a clone of itself, moving in the opposite direction. Okay. And I'll say it again, the day will end when all the food is being consumed, or when all organisms have eaten 2 pieces of food. Okay, so they are our starting assumptions for our model. Over the next couple of videos, we're going to try and translate that into code. That's the tricky bit. And what I really want is for you to work through these videos one by one and recreate the code. I'm not going to give you the code, right? It's important that your fingers do the work. And hopefully in a week or 2, maybe, I would like you to reproduce this figure here. So don't worry about what this looks like yet, because I'm going to show you exactly how to code it up. But let me just start at the beginning of this video. Okay, start here. So what I've done here is I've looped my one-dimensional line around on itself to make a circle, so it's a bit easier to visualize what's going on. I've got one red dot. Okay, so I've got one organism here in my environment, and all the blue dots correspond to pieces of food. So as this red dot moves, it's going to eat one piece and then another piece, and then the day's going to end, and it should spawn another clone of itself. There you go. So it just did that in the time it took me to click twice. And you can see on my graph over here on the right, it's a bit dark down here, but can I get rid of that? No. It's started to tick upwards. So I've gone from one organism to two organisms. And actually, it's already, I think, looks like it's calculating the second generation. And of course, as I click play, it'll increase exponentially, which is what we need. And then what you'll see here, went too far. There'll be a point when there is not enough food in the environment to sustain any further growth. Okay, so that's the sort of natural limit to growth, and it will just plateau out. Okay, and there you go. Right, so there you go. We'll start coding that up in the next video.